Hey everyone, this is Eddie Does Math. Here are some of the hardest SAT math questions. Number one, let's start off simple. If x to the 10th is equal to 5 and x to the 9th over y is equal to 5,555, find 1 over xy. Now, the main thing that I want to recognize here is I notice that if I put what I'm given, x to the 10th, and I put it over xy, I know this will be equal to x to the 9th over y, because one of the x's will cancel from both the numerator and the denominator. So I know this is also equal to 5,555. So how can I rewrite this? X to the 10th is 5. So 5 over xy is equal to 5,555. Now divide both sides by 5 in order to get 1 over xy by itself, and we get 1,111. And that's it. Number two, an equilateral triangle has perimeter of 1,500 feet. Now, this is a quick trick that I wanted to show you. If it has a perimeter of 1,500 feet and we have an equilateral triangle, then that means each of these sides will be 500 feet. We also know for an equilateral triangle, each of the angles are measured 60 degrees. If I created a little line that comes down here, we know that this other angle created will be 30 degrees. So now we have a 30, 60, 90 triangle. If the height of the triangle is equal to x radical 3, what is the value of x? So let's figure that out. We know in a 30, 60, 90 triangle, the ratio goes twice the shorter leg will be the hypotenuse. So going in reverse, this length right here is going to be 250, half of 500. So 250 times radical 3 gives us the longer leg. So x is going to equal 250. Now here's the trick. If you're ever given the perimeter of an equilateral triangle, divide it by 6, and that will give you the height of the equilateral triangle. 1,500 divided by 6 is 250. Don't forget that feet as well. Number three, what percent of the rectangle is shaded? Round to the nearest tenth. So we have this circle. We want to subtract that circle from the entire area of the box and then put everything over the entire area of the box because we want to know the percentage of the rectangle that is shaded. That's the most common misconception that students had for this problem. So first, let's figure out the area of this box. We know that the radius is 3, so that means here's one radius, here's another radius. So this side will be 6. So in total, we're working with 66 as our area of the rectangle. Now, from that 66, I'm going to subtract the area of the circle. The area of the circle will be pi r squared, r being 3. So that'll be 9 pi. When you plug this into a calculator, let's do that right now together. We'll get 66 minus 9 times pi. One more time. Let's try it again. So 9, let's try 9 times pi. And then subtract 66 from there. And then divide that by 66. And that will give us about 57.2%. So nearest tenth, so we have 57.2%, just like that. Number four, if the xy plane, in the xy plane, a circle has center -4, 0. So if we created a little graph here, we said -4, x, y. Here's the center of this circle. It's tangent to the line y equals -x. So -x looks something like this. And we know that y equals -x creates a 45-degree angle with the origin, or with each of the axes, x and y axes. So this is a 45-degree angle. Now from the center of the circle to a line that is tangent to the circle, we know that the radius creates a perpendicular, the radius is perpendicular to that tangent line. So given this, we know that we just created a right triangle here. A right triangle, not just any right triangle, but a 45, 45, 90 triangle. We want the circumference of this triangle. So once we know r, we can multiply r times the 2 pi. Great. So we know the hypotenuse of this said right triangle. I can redraw it here. This is a 45, 45, 90 right triangle, and our hypotenuse is 4. We know that the ratio is we take any of the legs of a 45, 45, 90 triangle and multiply by radical 2 to get to the hypotenuse. So in reverse, we're going to divide by radical 2. and this can be rationalized. 4 divided by radical 2, I can multiply both the top and bottom by radical 2 to get 4 radical 2 over 2, which is 2 radical 2. So that is my radius. So the circumference of the circle will be 2 pi times 2 radical 2, and that leaves me with 4 pi radical 2, and that would be my final answer. On the SAT, you would probably have to plug this into a calculator and then estimate or round to whatever they give you, nearest tenth, nearest hundredth, nearest whole number, whatever it may be. Number 5, f of x is equal to a to the x plus b, where a and b are constants. Students tend to confuse or get confused about what a constant is. Basically, a constant is just any number. Don't get confused, right? A constant is just any number. It could be an integer, a rational number. It could really be anything as long as it's a real number. Now, y is equal to f of x minus 11 passes through the point 0, comma negative 29 over 4. So what that means is that when I plug in 0 into x, I will get negative 29 over 4 for my y. So let's write that down. Negative 29 over 4 is going to equal f of 0 minus 11. I want to figure out a if we know that ab is equal to 66 over 4. So let's figure this out. The most common misconception or mistake that students made was that f of 0 will equal 0. But be careful here. F of 0 will equal a to the 0 plus b. Anything to the 0 power is 1. Or they said f of 0 is just going to be b without that 1. So that's what led to student mistakes, or the most common mistake. So f of 0 is 1 plus b. Let's plug this into this f of 0 because that's what it is. So now we have negative 29 over 4. 29 over 4 is equal to 1 plus b minus 11. 1 minus 11 is negative 10. I can add 10 to both sides here to get b. So b will be negative 29 over 4 plus 40 over 4. And so b will equal 11 over 4. Now, if b is equal to 11 over 4, and we know ab is equal to 66 over 4, this is actually a really neat problem. Because without multiplying both sides by 4 over 11 or anything like that, we know that 6 times 11 is 66. The denominator is 4, so a will simply be 6. Nice and simple. Number 6, we're 3/4 of the way there. The measure of each interior angle of a shape is 5 times the measure of each exterior angle. So imagine a shape that has an interior angle like this. That interior angle is 5 times the measure of each exterior angle. So here is our exterior angle. Let's call our exterior angle x. And then we can call our interior angle 5 times that x. And now what do we know about this? Think about it for a second. We have 5x and x. We know that they create a straight line. A straight line adds up to 180 degrees. So 5x plus x will equal 180 degrees. So we have 6x is equal to 180, and x will be equal to 30 degrees. So how many sides does this shape have? If x is equal to 30 degrees, we know that all the exterior angles of a shape add up to 360 degrees. All the exterior angles of a shape add up to 360 degrees. So if we took 360 degrees and divided by one of these exterior angles, that will give us the number of sides of this shape. So we have a dodecagon here, 12 sides. Number 7, in how many ways can a 4-digit number be formed from this set of numbers, 0, 1, 2, 3, 4, 5, if no digits appear twice? Okay, so we have a 4-digit number. Here are the 4 digits. How many of these numbers are allowed to be used for this very first digit? And this is where the most common mistake happened for students. They said 6. But why is this number not 6? Well, some might say, well, we have 6 numbers here, Eddie. You just put a 6 here. That's how many digits work here. But for any 4-digit number, the first digit cannot be 0. So it's actually only 5 numbers can be used here, 1 through 5. Now that we've used one of 1 through 5, how many numbers can we use for this second digit? Well, we used 1 through 5, but 0 still exists. 0 can be put for this digit, so still 5 numbers can be used. And after that, we eliminate 1 at a time, 4, and now only 3 digits can be used for this last, or 3 numbers can be used for this last digit because no digits appear twice. We multiply these out, and we get 300. And that is the number of 4-digit numbers that can be formed from this set of numbers 0 to 5 if no digits appear twice. And the key here is that 0 cannot be used as that very first digit. So slightly tricky there. Number 8, this is a beast problem. If you can get this, you're on your way to an 800. If the figure below, segment CE, in the figure below, segment CE is the diameter of the circle and has length 150. So CE is equal to 150. Segment CE is perpendicular to segment AB. Great, given. At point D, if BD is radical 296, and CD to DE is equal to K. So this is a ratio that we want to figure out. Find the value of K. Great. Let's draw some similar triangles, because right now what we just learned, from what we learned, we have a bunch of similar triangles here. We know that, oops, I put BD in the wrong place, by the way. I put it at ED instead, but BD is equal to radical 296. Let's create some proportions. Let's first draw the triangles that we know. So right now we know BDE, and we know this is 296. Let's call, since we don't know what CD or DE are, let's call CD X, which means that DE will be 150 minus X. And how do we know this? We know this because we were told that the diameter of the circle, CE, is 150. So if one part of it is X, then the other part of it should be 150 minus that X. Okay, great. So DE is now 150 minus X. So now we do have a smaller triangle here that's similar to triangle BDE, and that triangle is CDB. And CDB, we have X for CD and radical 296 for DB. Notice how these two triangles share the side BD. One's here and one's here. And now we can set up a beautiful proportion. We can set up radical 296 over X is to X as 150 minus X is to radical 296. Now we can use the butterfly method here, cross multiply or multiply both sides by the denominators, whichever of those ideas that you like to use or skills that you like to use, any of them work, but eventually you will get 296 is equal to 150x minus x squared. And now since we have a quadratic equation, we may be able to factor. Let's move everything to one side. We'll have x squared minus 150x plus 296. So equal to 0. We can factor this into x minus something and x minus another thing. Those two numbers will be 148 and 2. Great. So that means we have x equal to 148 or 2. But now let's think about it. Can x be 148 or 2? Well, if x is 148, that means this long piece is going to be just 2. If x is just 2, then this long piece will be 148. So we just found our answer. CD, the shorter side, is going to be 2. And DE, the longer side, is going to be 148. So K will be equal to, once we simplify, 1 over 74. There we have it. If you got all 8 of these problems correct, you are on your way to an 800 on the SAT Math section. If you found this useful, make sure to subscribe and check out the description below for links to my courses. See you soon.